Okay, so last time what we did is we had GitHub. I was using GitHub Desktop here to clone the repo. By the way, there's an update for GitHub Desktop like every day, so that's normal. Don't worry. I had the repo cloned and it's on my computer. If you didn't do that yet, go to the link on the website, fork the repo, and then I'm using GitHub Desktop to clone it to my computer. All right? So I'm starting today assuming you have this done. So you can see here, I put it here on my desktop. Now, I already ran this because it takes a few moments to set up. And by the way, this will work if you're using PyCharm. This will work whether or not you have Python installed on your computer. PyCharm will actually install Python for you if you don't have it. It's really nice, actually, because installing Python on Windows is kind of weird. So here's what I did. I'm opening up PyCharm. Okay, so I'm opening up raise your hand if you're going to be using PyCharm. Raise your hand if you're going to use like Visual Studio Code. Okay? Don't ask me how to set it up. Run the virtual environment setup. You can run anything here. As a note, if we go to GitHub, where's 340? If you go here, I mean, this shows you how to like create a virtual environment and run and do all the setup you need to do. But I don't know how exactly that would integrate into VS Code. But there's that. Good luck figuring it out. People did it last year. If you know Cole McDonald, ask him. He figured it out. So here we go. I said open project. I just navigated to where it was. It's on the desktop. Loading. Come on. Okay, let's go home. 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 Desktop. Apparently this is very difficult for it. All right, well, maybe PyCharm is not going to cooperate today. Well, if you're following along, I'll give this a moment. Maybe it'll figure it out. Navigate to the project directory. You just need to get to like the root directory, basically, just like the top level within the folder where it is, and select open, right? And then it'll say like, oh, do you trust this project? Yeah, you can trust it. I didn't do anything harmful, at least that I'm aware of. So you should be fine. You trust the project. And then if you're using PyCharm, PyCharm will say, hey, wait a minute. There's a setup file in here that tells me how to set up your virtual environment and get everything working. Ah, here we go. Perfect. Okay? So I hit open. Now, mine's not going to do that because I did that already. I already said, yes, run the setup. You can ignore this pop-up. But you're going to get a pop-up that says, do you want to run the setup? Say yes. It's going to do all of the annoying work for you and you're going to be set. So say yes, but I'm going to warn you. It's going to take a few minutes to do everything because it might need to download Python. It's going to need to download all these external libraries. It's going to have to set everything up. It's going to take a few moments. So don't panic. Just let it do its thing. So what I'm going to do, while people are having their Python do the setup, I'm just going to walk around and see if people run into questions and problems as we go. And then once it seems like most people have everything set up and ready to go, I'll continue. Cool? Any questions? Yeah?
Does school have a license for students for PyCharm?
For PyCharm, you can always get the access to the Community Edition, which is free. But as a student, you can sign up with like JetBrains and be like, I'm a student. And then they give you access to all the good stuff for free. Now, I will say, for our purposes and for most students' purposes, the Community Edition is sufficient. The Professional Edition has a lot of tools that are really meant for like big teams and whatnot. But, I mean, use what you want. I mean, the whole reason they give you it for free is they want you to get hooked. And then when you get a job, they want you to give them money. But, you know, I'm using the Professional because I just have like an indefinite license. They're nice to professors because, again, they want me to convince you to use it. But, yeah. So I'm just going to walk around for a little bit and just see how people's setups are going. And if they run into anything, I'll see if I can help. But no guarantees there. No promises. Okay, you're setting up that license. Looks like, yeah, it's getting...
Yeah, I tried, but the first time I tried it said failed to install Py project, but then
thing says it should automatically install it. So.
All right, good luck. What's up?
Where do I go from here? Like I've got to open a VS Code. What am I doing right now?
I mean, I don't know if the setup for the virtual environment's there. You should have like a. Do you have like a terminal?
Yeah, you have to like.
Open up the terminal and basically copy and paste the setup. You're on Windows or Mac?
I'm on Mac.
On Mac, then it's probably going to be the Bash one.
Yeah. Okay.
So if you go back to the GitHub thing,
Yeah, I can open a Bash terminal.
yeah,
Send it to
open up the Bash terminal, copy paste it there, and I assume that's how it would work. But honestly, I don't actually know. Yeah, that's the one you're going to want.
Oh.
That one. That's the window. You want the Bash one.
Okay.
Pardon?
VS Code?
Yeah.
I can follow your system then.
Okay.
Can you just have any problems?
Cool. And yours is, looks like yours is all set up, yeah? To confirm if you did the setup and you want to confirm it's working, let me just show you. Just go to like the source directory, src, and open up GA max bitstring. That's the one we were doing the other day. If you look at this code, it's basically the code that we walked through before. You can run this one. And if everything runs, like if it runs and you see output similar to this, you know everything worked properly. Raise your hand if I'm not expecting that you have it done at this stage, but raise your hand if like, yeah, this worked. You could run it and it worked. Raise your hand if you're in the process of getting set up in order to run it to work. Okay, cool. Yeah, I know the setup takes a few moments on PyCharm. Took my computer way longer than I expected. So just as a note, today, so who here has had me as a prof before? Okay, about half of you. So today's lecture is going to work mostly like how my labs have worked, where you just kind of work through the stuff today. There's not going to be a lot of lectures like this, but there are some where I want you to spend the time and kind of figure this stuff out. So yeah, while everything's getting set up, I mean, if your computer's like, hey, help me, pay attention to that. I want you to get set up. But I will explain a little bit here first. So what I want you to do first is everything's set up. I want you to run the code. I want you to run the GA and like max bitstring script, whatever it is. That is a genetic algorithm that's going to optimize the bitstring to be all ones. Now, if you go to the code and you scroll down to the bottom, you'll notice some stuff that's commented out. You could uncomment this out and run it, and then you'll see a plot. And the plot, this is like the plot of fitness over time. So here we could see this is the generations, this is fitness, right? I'm guessing this is a 10-bit string. Could be wrong. And I have two things plotted. I have the best, each time the population will have a chromosome that is the best. It might be tied for the best, but there will be a maximum fitness value. That's the blue line. And this like orange line, that is the population's average fitness, okay? Now, there are a couple of things I can notice from this that's quite interesting to me. I mean, at one point, look, the average and the best is basically the same at one point, which to me is pretty damn indicative that our population has what we would call converged. In this particular example, every time you hit run, you're going to get a different plot, to be very clear, because everything's like, there's all that randomness involved, right? But I look at this and I say, okay, the population by generation, I don't know, like 817, let's say, it looks like the population has converged. And what that means is if all of the, I mean, in the context of how this one is built and how we're measuring fitness, what is the binary number? If they all have the same binary number, that means they're all the same binary number, meaning that the population is full of all of the exact same binary number. The population has converged. And usually when that happens, you don't really get a lot more learning taking place, especially from crossover. Mutation is going to be the one that will make any positive change. Because if you have a population, they're all identical, and you start doing crossover, It's not going to change anything, right? Imagine doing that 1-point crossover and they're all the same. No matter what you do, they're going to end up being the same. So it's going to have to be the mutation that makes any change. So clearly at this stage, it wasn't until mutation did something good where the fitness was able to go back up.
Which is funny because while the fitness skyrocketed, the average dropped.
Well, I mean, it can happen in a bunch of places, and think because mutation can make a change that makes it worse, right? And the same thing could happen to the best. The best, we might actually lose the best thing out of the population. Although there are strategies we can do to kind of address that. And these are the settings I used for my evolutionary algorithm. If I scroll up at the top, I assume these are the same settings. 10, 10, 2, 25, 70, 10. 10, 10, 2, 25, 70, 10. Perfect. So here, what are these constants? Well, the top one is, well, that's basically how difficult the problem is. How big is the bit string I want to maximize? That really doesn't have anything to do with the genetic algorithm itself. That's more about the problem the genetic algorithm is being applied to. If I make the bit string bigger, the problem gets harder because there's more bits to turn into ones. Then we have a population size. I set it to 10. In practice, this is a hilariously small number. Usually your population is going to be like 100, 1,000, and so on. Generations, tournament size 2. Remember, for selection, I got to pick a subset of the 10. I picked 2, took the best of the 2. 2 is a good number. You can make it 3, 4. Remember, as you make that number bigger, your likelihood to always pick the best one goes up. When you make that number smaller, it's more like random in terms of what you're going to get in terms of its goodness. But I picked 2. By the way, why is the population size of 10? Why must it be a multiple of 2 based on the implementation we saw? Can anyone tell me?
Because you're swapping stuff in pairs.
Yeah, exactly. Because the way I implemented it was rather lazy. When I was doing the mating pool, if I have a population size that's an odd number and I'm always trying to do crossover on pairs, and there's an odd one out at the end, so that's why I made it even. So this is just an easy way to do it. If there was a software engineer here, they'd probably cringe and be like, oh, you should never do that. You should protect, whatever, I'm lazy. Tournament size 2, generations 25. Again, that is a hilariously small number, usually for a sufficiently difficult problem that you would be using a genetic algorithm for. You're going to look more like hundreds, thousands, millions, billions of generations. That's normal. But you always set these values to each individual problem. A crossover rate of 0.7, so 70%, and a mutation rate is 10. These are reasonable numbers to kind of start with, I'd say. So if I go down here, I'm going to uncomment this out. No, how do I do that again? D? No. There we go. All right, and now let's run this again. Run. And there we go. Look at that plot. Looks way different than the other one. I'm going to run it again. And look, the best fitness actually went down off the start. Let's rerun it. Oh, it's different. Similar, but different. Similar, but different. Ooh, that one's fun. Right? Every time you hit run, it's a little different because of all of the randomness. The population was randomly generated. Which ones were selected was random. Who the genetic operators were applied to, both crossover and mutation, were random and random. And where crossover was done was random, and where mutation was done was random. There's so much randomness involved that there's no determinism in a whole run. It's not going to happen. So that's why it's going to be different. So raise your hand now if you can run it and you're all set up and you're good to go. No, it's still setting up PyCharm?
I had it down, I recalled it like 2 times, like it like set up from that, messed up.
All right, well, we'll give it a few more minutes before I carry on. Worst case scenario, work with the person next to you. All right. So there we go. And like I said, let me close this, close. This is the same code that we looked at in the topic. Value fitness, calculate, ignore this one for a second. calculate the binary value of it. Then, okay, generation max fitness, generation average fitness, populate. By the way, for those of you that don't know, this right here, who here's, for those of you that have been using Python a lot but are not aware of like what that line is, that if name is main or whatever, the problem is there's a lot of code in here that can be like imported. And if you import any code, the code that gets imported, like if I'm in another script and I import this script, when I import it, all of the code in the script I import runs. But you'll see there's a bunch of like there's a whole GA here. And if I import it, I don't want a whole GA to run. So what this says is only run this code if I was explicitly running this script as like the main script. If I import this script elsewhere, don't run this code. Just everything else is fine. That's what that means. So there we go. Cool. Any questions about what we're seeing here? All right, yeah, okay. So generate the population. Then we've got our generation loop. Calculate the fitness, bookkeeping, do selection, do crossover, do mutation, update the generation or the population to be whatever the mating pool was. Repeat, 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 repeat until the generations are done. Do one final evaluation of the chromosomes because remember, we evaluate and then change the chromosomes. So when the loop finally ends, the chromosomes were changed before any last evaluation was done. So we have to evaluate one more time. And then it's just bookkeeping some results. We see down here, what am I printing out? I'm printing out each chromosome's fitness. It's a population size of 10. We've got each chromosome's fitness followed by each chromosome, like the whole population is printed out. There we go, cool. So looking at this, 1023, that's the best number when n is 10. 1023, 1015, that wasn't the best. But it looks like everything except 1 actually got the max value. So what's going to happen if I make the problem harder? Like if I make it 20, or let's make it 32. No, let's make it 30. If I make it 30, well, you can clearly see, like look, what's 2 to the power of 30 minus 1? A big number, right? But we can look at this and we clearly know it's not the best solution, right? And how do I know it's not the best solution? Well, there's zeros in it. As I make the number of bits bigger, the problem gets harder. And if we look at this plot, well, yeah, let's rerun it. That's not too bad, right? But it's like all over the place, right? So clearly, I'm not getting the best results. So what could I do? Well, I can make the population bigger. Let's make it 100. But if I make the population 100 in 100 generations, it's going to take a little longer to run. But, we're getting there. But now look, it looks like we actually got the best numbers. So, with different difficult problems, you have to start to tune these values in order to get good results. Okay, raise your hand if you're ready to go, you can run your code. Cool. All right, so with that, I'm going to have you just go through and follow the exercises. So if we go here, experiment. For all the following questions, take time to run the GA with several values and plot the results. And this is just saying, yeah, run it. But I'm giving you a series of things to do. And I just want you to work through that. First, what I'm going to do is have you work through the first 10 questions. Okay? And after that's done, I'm going to talk a little bit more, and then I'm going to give you more stuff to do. Cool? Cool. Awesome. For the sake of the video today, I'm going to pause the recording. Pause. So I'm going to pause. It's paused. Okay. I've unpaused the recording, but we're basically done. Raise your hand if when you open it up in PyCharm, PyCharm was like, hey, there's a setup, run me. a couple of people. Some people it didn't, but then it was like missing packages. Do you want to install? And so some people, it seems like people are getting inconsistent results. At the end of the day, you're going to have to get this running. So start to figure it out, see if you can get it going. I'm sure you can get it figured out. You're going to want to get it done for Friday, because Friday I'm not going to help you get your computer set up to run Python. We got to get moving with the content, okay? Cool. All right, I'll see you all later.